Researchers have developed a low-cost device that can selectively capture carbon dioxide gas while it charges. Then when it discharges, the CO2 can be released in a controlled way and collected to be reused or disposed of responsibly. The supercapacitor device, which is similar to a rechargeable battery, is the size of a 2-pence coin and is made in part from sustainable materials including coconut shells and seawater. Designed by researchers from the University of Cambridge, the supercapacitor could help power carbon capture and storage technologies at much lower cost. Around 35 billion tons of CO2 are released into the atmosphere per year, and solutions are urgently needed to eliminate these emissions and address the climate crisis. The most advanced carbon capture technologies currently require large amounts of energy and are expensive. The supercapacitor consists of two electrodes of positive and negative charge. The research team tried alternating from a negative to a positive voltage to extend the charging time from previous experiments. This improved the supercapacitor's ability to capture carbon. The researcher says that they found that by slowly alternating the current between the plates, they can capture double the amount of carbon dioxide than before. The results are reported in the journal Nanoscale. A supercapacitor is similar to a rechargeable battery, but the main difference is in how the two devices store charge. A battery uses chemical reactions to store and release charge, whereas a supercapacitor does not rely on chemical reactions. Instead, it relies on the movement of electrons between electrodes, so it takes longer to degrade and has a longer lifespan. The trade-off is that supercapacitors can't store as much charge as batteries. But for something like carbon capture, the researchers says they would prioritize durability. The best part is that the materials used to make supercapacitors are cheap and abundant. The electrodes are made of carbon, which comes from waste coconut shells. However, this supercapacitor does not absorb CO2 spontaneously. It must be charging to draw in CO2. When the electrodes become charged, the negative plate draws in the CO2 gas while ignoring other emissions such as oxygen, nitrogen and water, which don't contribute to climate change. Using this method, the supercapacitor both captures carbon and stores energy.